Good morning to everybody. I would like to start with some information or data that we gained from the validation or verification of the implementation of the Watchmaker DNA library prep genomic kit from Watchmaker Genomics. I have somehow conflict of interest because I'm employee of the private company that is doing NIPT, but no conflict of interest regarding the Watchmaker Genomics. Only short introduction to the NIPT. I am almost sure that every one of you knows what is NIPT, but we are analyzing circulating DNA that is in pregnant women composed of maternal and fetal DNA, or even more properly, not fetal, but placental one. It enables testing for somehow screen for some specific issues, screening, testing or screening for fetal chromosomal aneuploidies and CNVs. And mostly over the all the worldwide mostly used method is the low coverage whole genome sequencing. What is the parameters of the material that we are working with? The proportion of fetal DNA in this whole circulating DNA from pregnant women is on average 10% at the 11 to 13 gestational weeks, what is the window in which the most of samples are coming to our lab. We know that naturally the DNA that we are analyzing is fragmented, so we don't need to fragment it anyway. We started with already fragmented DNA, and what we know from the previous research of the different groups that the fetal fragments are shorter than maternal ones. Roughly it is 143 base pairs for the fetal and 166 base pairs for the maternal fragments. We know that fetal fraction is increasing with gestational age. Till the 20th week of gestation, it is slower increase. After that, it is more fast increase. And this is something that is used if we are having from the first blood sampling a low fetal fraction, we are able to postpone the second blood draw and to repeat the analysis and to get more reliable data or informative results. And that's because for all NIPT, the fetal fraction is something like hard cutoff, some limit. Different methods show different numbers, but in reality, it means the same, that if you have too low fetal fraction, you are not able to give quite good result. Naturally, it means that 0.5% of pregnancies are for any test low fetal and so uninformative at the end. What are the parameters that are critical in our laboratory for the genomic library prep kit? We are starting with very low input of DNA, and it means low input from volume and concentration point of view. We would like to work with different indexing kits, so the compatibility with different indexes kit is also one of the important parameter. Of course, as any routine laboratory, minimal sample handling is critical. More sample handling means more potential errors performed by the people or any kind of degradation of the sample, so it is really critical. Then, of course, speed, robustness, consistency of results, and overall performance from the point of view of real detections of true positives and no detections or as low as possible detection of false negatives. We have also the request for the Watchmaker Genomics regarding the IVDR procedures that we would like to go for something like OIM version of the kit, and they are supposed to do that. So it was really important for us regarding the dates or deadlines that are approaching all of us in the lab. Sorry. Then, of course, sales and technical support, we get great one. And of course, the parameter is the competitive price, because all of us are pushed by the prices in our labs. We are comparing previously used and validated method that is called in this presentation as a reference, and we have been using for a long time through Signano DNA library preps, and then we are comparing it with the Watchmaker Genomics kit. Basic difference, and especially historically, the True Signano was recommended, or the Illumina was recommended to start with 50 to 200 nanograms, we never get these high numbers from the DNA extraction that we are preparing in our labs. Nevertheless, this method is still running also with a low concentration, much lower concentration successfully, as we know from our history. But the watchmaker genomics directly recommends or enables starting with 0.5 to 1,000 nanograms. And this is something that we are looking for, so to start with very, very low concentration or amount of DNA. Short introduction also to our protocol. We are doing the DNA extraction that is starting from less than 700 microliters of plasma. And we are having theoretically DNA input between 0 and 0 like that, because it is, of course, not 0, it's 0 point something. And the highest, or for most of samples, the highest amount of DNA is 10 nanograms. We are trying to optimize the protocol to enrich the DNA library, or directly the extracted DNA, for a fragment size around 150 base pairs. And we are running our DNA libraries on Illumina NextSeq 500 and 550 platforms, and we are preparing it also for NextSeq 1000, 2000, and any other NextSeqs, or also some competitors that are now coming to the market of genomic sequencers. Here is the distribution of the DNA samples when it comes to the concentration we are dealing with. You can see that we are not having something between 0 and theoretically 0.1 nanograms per microliters, and it is because the fluorescent method that we are using for DNA extraction do not differentiate at this range. So we are starting even at 0 or afterwards at 0.1, and we are ending at 0.3 nanograms per microliters, because we know from our previous validations that after that limit we are having more samples that are degraded from the point of view of maternal cells in the plasma DNA, or the plasma DNA then contains more maternal DNA, so it automatically decreases the fetal fraction in the analysis, and that's something that we don't want. In that cases, we are asking for second blood draw, because the most probably there was a degradation of sample before it arrives to the laboratory. When it comes to the protocols, I told you something about that we are looking for minimal sample handling, and we are seeing that when we are looking on hands-on time, that's the gray boxes, and on overall time of the protocol, the black boxes, we are getting 60 minutes less when we are working with the watchmaker genomics kit in our hands. And it means the whole procedure that is starting with the plasma separation till the sequencing start of the sequencer with the genomic library means for the TruSeq Nano at least 570 minutes, and it's 60 minutes more than standard work day has in our country, in our lab. So it's more than 1 day then. When it comes to the watchmaker genomics, we are exactly at the time of 1 working day. So we are able, if it's necessary and needed, and there is something very important to work on, then we are able to prepare everything from the sample to start of sequencing and analysis of the sequencing that is then running in the night after the sequencing is ended in less than 24 hours. When we are starting, or when we were started with where we did start with the watchmaker genomics, and we were using the original protocol, of course. This is the optimized protocol for reference methods, and this is the original protocol for watchmaker genomics. Of course, we have seen that it is necessary to optimize it somehow, but with very simple optimization steps that we are routinely performing in our lab, we are getting similarly and clear profiles from the genomic distribution over all chromosomes that we are analyzing in our NIPT test. Of course, we are looking also for more robust and more consistent results from the library prep. You can see that the reference method have some different amounts of genomic libraries prepared from, of course, different amount of DNA at the beginning. But when you are looking on the consistency of the peaks, you can easily see that it is more consistent on the same samples that the watchmaker has. When we started with the pilot study, we have been also surprised that we are getting the higher fetal fraction for different set of samples. And for the fetal fraction, we usually compare female fetuses with male fetuses. And in this case, we also added some monosomy X containing fetuses. So we are in all subgroups seen, or we have seen that the fetal fraction was significantly higher for watchmaker genomics. This is something that was not confirmed later on the larger, much larger validation or verification study or routine testing. And that's because, of course, if you are starting to do something with a new kit, you are always afraid to do some specific steps as soon as possible, as fast as possible. So this is something like special treatments anytime, while these samples and results from the reference method have been used from the routine. So this was something that we have analyzed before, and then we get the samples from the stock and repeat it with the new kit. So this was the reason, at least we thought, we are thinking that this is the reason. Nevertheless, it was also surprising for us that it is possible. So if we will play with all the samples like that, we will get really higher fetal fractions from all samples. Then we have performed a pilot study where 62 samples have been selected with different aneuploidies and copy number variants that we have been using before and that have been reported before. With the reference method, you can see the different trisomy samples that have been analyzed. This is something like a reference result for the trisomy 21 containing fetus. You can see that it is easily detectable with the method. We have similar results with more exotic, we can tell trisomy 16, and we are able to see also similar detection, similar clear detection of the copy number variant on chromosome 18, the short arm deletion. When we are looking at the more robust data, we, of course, after that pilot study, involved in the watchmaker genomics kit in the library preps for some time. It runs parallel with the reference method. Afterwards, we are only working with watchmaker genomics kit. So together in the verification study, almost 7,000 samples have been analyzed. Two different numbers and the differences we are getting in next slide, or today they summarizing. Nevertheless, in this verification study, we have seen that genomic libraries, when it comes to the nanograms per microliters concentration, the watchmaker genomics was giving us lower concentration. Nevertheless, the peak was much more narrow. So this is something that we have seen also in the gel-like graph or image, that the data have been more consistent one. And this is something also important in our lab, because if you have very diverse concentration, you have some problems with the pooling of the samples before sequencing. So you have to do some extra dilutions for the highly concentration samples to pool it in the same manner. So this is something that we are also, that we also like, that the peak of the concentration is much more narrow. So no extra dilutions, less work for the people in the lab. But also with the lower concentration of DNA, we are able to get the similar fetal fraction, and this was something that I mentioned before, that all through in the pilot study we have seen overall higher fetal fraction. Now it is the same. But also with the same fetal fraction, the distribution of the samples with a lower fetal fraction, and this means lower than 4%, was lower for the watchmaker genomics kit. So you can see that if it is compared of the fetal fraction below threshold, we are getting better results from watchmaker genomics. Then it is about the distribution of the sequencing reads or the libraries mapped to the chromosomes that we are analyzing, that also this proportion of the uninformativeness based on worse distribution of these reads is lower for the watchmaker genomics, and in the end the total uninformativeness is 1% less. And in our method, 1% means a lot. This is really something that we are communicating with the pregnant women, and they are asking, what is the risk that my sample can't be analyzed? So at least at that point, we are really better with the watchmaker genomics kit. So to sum up, all the parameters and critical issues related to our testing in our lab was fulfilled with the watchmaker genomics, and therefore we are now running only on this kit all our routine. Thank you for your attention.